Well, hi everybody, and welcome to Dome at Home, the Manitoba Museum's planetarium astronomy show. I'm your host, Scott Young, and it is great to see you all today. Sorry for the delay. We were, of course, supposed to be on last week, and we'll get into the story behind everything as we go through the show. But suffice it to say, we have a program now, and we have another program next week. So even though we're supposed to only be going monthly, there's going to be something else coming up next week that will be online as well for. I was just trying to say hi to everybody in the chat, and I wasn't able to type fast enough, as Philip pointed out. Yeah, my spelling is pretty bad most of the time. When I'm trying to race to say hi to everybody, it's much more of a challenge. So, hi. Thanks for joining us. It's great to be back doing this show on a somewhat regular basis. For those of you that are new, we started this back in COVID when no one was allowed to come to the planetarium. And then it was just so much fun that we just kept doing the show. So we talk about what's up in the sky, we talk about cool space stuff, and we have special features and guests and things like that when it's appropriate. All right. So today we are going to mostly focus on the upcoming solar eclipse. I was going to be broadcasting live from NASA tonight, and that's why we moved the show, because we thought it would be really cool to broadcast live from NASA. But then the launch that I was invited to attend was delayed due to a technical error or thing that they had to fix. And so I will be leaving next week, and the launch is next Thursday at 9:16 a.m. Central Time. I know that's not the best time for a lot of you, but 9:16 a.m. Central Time, a SpaceX Falcon Heavy, that's the big rocket with the two side boosters, will go up into space, and take the Psyche asteroid mission on the first leg of its journey. Psyche, we're going to talk about the mission a little bit later on in the show. But it's a really cool one, and it is kind of amazing that I'm going to be able to see this launch up close. So I'll tell you a bit more about that as well. But anyway, that's the reason for the scheduling changes. Some of you wrote in and asked if everything was okay. Yeah, no, everything's fine. Just kind of a. We thought it would be cool, and then NASA changed. So that's where we are. All right. Oh, I got some bless yous there for the sneeze. Yeah, thanks. Okay. All right. Let us get started with you. Let's start with some of the viewers' images, because since we started our first show again after our break last month, some of you have started sending in pictures, and I went back and I found a couple of them. I know that there are more pictures that people sent me in the last several months, and I wasn't able to put all of them into the show today, so we're going to be sort of cycling through those over the next little while. But if you do take any pictures, or you do your sketches, or anything like that of anything astronomical, we love to see them here. You can send them into space@manitobamuseum.ca, and we'll be glad to show them off to other people. I find that people get inspired when they see other members of the audience, other members of our community out there under the sky doing things. So let's start off. Andy and Ruby sent me some regular emails over the last little while. This was a picture from back in March that at the time I didn't have a chance to look at, but that was back when Venus and Mars were sort of right next to each other. I remember trying to go out that night, and I think I saw it the night before, but I missed it this night because there were clouds. So good on you there for getting that shot, Andy. Nice view of those planets. Ulrich was out observing the comet. There was a comet very recently that came by. We thought about talking about it in the September show. It was initially forecast to be quite bright later in September, but some of the forecasts I felt were a little overly optimistic. And in fact, that turned out to be correct. You were able to see it if you had decent binoculars and you were very studious. And of course, Ulrich is perfect for that. She was out there and managed to find the comet, even saw a little bit of the tail there. It was over in the early morning sky, and it was very, very low in the sky. So it was quite difficult for us to see here. Folks farther south, where a lot of these predictions are often written, had a bit of a better chance to see it, and that's why it sort of blew up on the internet for about a week or so. But it was not nearly as bright as it was supposed to be. Comet Nishimura was interesting because it's named after a human instead of most of the comets that we see recently, like Comet Zwicky Telescope Facility, or Comet ZTF that was visible a little while ago. Those are usually found by robotic telescopes that are just manual or automatically searching the sky. This was found by a guy looking through a telescope who knows the sky so well that he can recognize when something is out of the ordinary. And actually, Mr. Nishimura has found a couple of comets in the last few years, which is really amazing. You think that with all of this technology that is being used to scan the sky, what would the machines be missing that a mere human in their backyard with binoculars could pick up? Well, turns out quite a bit. So great job tracking that down, Ulrich. It really is I found it very difficult because of how low it was, and you did a great job bringing it down. This is another Andy and Ruby shot, and this is another comet. This is that Comet Zwicky Telescope Facility, or ZTF. You might not easily see it in there, but I love this shot. Andy was playing around with his camera and doing the process of stacking pictures. So it's not just a single picture. You take a bunch of pictures and then overlay them. And what happens is all of the static, the digital static and noise that is in each individual image sort of gets suppressed, and the main picture gets better and brighter. So this was a great way to pick that out. Let's see if we can... There's the comet there, quite small, and it does have sort of a bluish color and a little bit of a tail up towards the top left there. But I mean, if you look at it really close, here we'll zoom in a little bit, you can tell it's not a star. It's definitely a comet-like object. But with this picture, I'm not even sure that the comet is really the highlight of the image. Let's go back to the wide view here. This is a beautiful shot of part of the winter sky. Auriga is up over here on the left. This is the constellation Auriga. Capella is just off the top of the frame there. Mars is over here. We've got the Pleiades over on just over my left shoulder. And then a series of star clusters, the winter star clusters. M35 is down at the bottom right. M37, 36, and 38 from left to right across Auriga there. And they all show up really, really nicely in this picture. So this is a great shot, and definitely a technique, I think, Andy, that works really well for you. So good on you. Keep trying that out. Okay, I'd love to see any of your pictures and any of the things you want to send in. Could be a drawing, could be a poem you write when you're inspired about the sky. I mean, how you record things and how you remember things in the sky is really up to you, and it really doesn't matter whether it's, sort of the way that it's always been done or a brand new way to do it. You can hit us up on social media, or you can email me at space@manitobamuseum.ca, and I would love to see what you're doing out there. Even if it's just sort of a story of, you're observing or a nice view of the constellations or aurora. Did anybody see aurora last night? I guess it was raining here, but if you're farther afield from Winnipeg, drop it into the chat there and let me know if you did see the aurora. There was sort of a spontaneous, unexpected little burst of northern lights over the last couple of nights, I think. So I'd like to see a little bit of that. All right, let's go to I'm just going to make sure I didn't miss anything in the chat here. Lots of compliments on the images, and Ulrich is a pro with her binoculars. That is correct. We're going to have to get Ulrich back for that binocular feature of the month that we were doing for a while. I think we have to get that going for next month. Ulrika, this is notice. Remind me. We'll talk. All right, let's get back to the October sky. Now, here in Manitoba, October is not usually the best month for stargazing. September was wonderful. We have still relatively clear skies, but most of the mosquitoes are dead. The temperatures are not too cool at night, and we still have these views of the summer sky and the early fall sky. October is when it gets cloudy, and November is even worse. So you have to take whatever days you can at this time of the year. But we'll take a look at what's up in the October sky, where the constellations are. We'll take a look at the planets and so on. And that way you'll at least be prepared for whatever, clear night, or maybe even just a clear half hour or something like that you might get to take a look at the sky. Right after sunset, off in the west, the sun's setting pretty much due west now. Well, I guess it's a little bit to the south of west now as we've passed the equinox. You've got a fairly bright star that appears fairly early in the evening. That is the star Arcturus. It's a very bright, kind of orangey yellow star. And if we get it just a little bit darker here, we'll start to see some of its surrounding constellations. It's part of the constellation of Boötes the herdsman. I'm just going to make sure that, is my pointer working here? I don't know if it is or not. Yes, there we go. So Boötes the herdsman is made up of this group of stars, which of course looks exactly like a herdsman. To me, it's the ice cream cone, and there's the ice cream on top. Arcturus is a nice signpost for the seasons, though. You first start seeing it in the springtime. It's visible all summer, and in the fall, it's starting to fade away into the west. So it really is sort of a fair weather kind of star, and it disappears usually around the time the snow hits, at least for us. A little bit farther to the northwest is our familiar Big Dipper. This is the worst time of the year to see the Big Dipper as well, because it's down quite low, and the other stars here that make up the constellation of Ursa Major, the Great Bear. Yeah, I better turn on the lines here to make that a little bit more clear. Does that help? Not really. I don't know how this is supposed to be a bear. To me, it kind of looks like a giraffe that is jumping and running that way with some kind of, I don't know, it's a giraffe wearing a kilt? I'm not sure. Anyway, the constellations, obviously, most of them don't look like what they're named after. Certainly not the official Greek ones. Some of the First Nations star groups, the Anishinaabe and the Cree, for example, have different animals that they've named this after. This is the Great Bear, but it's also the Fisher, which is kind of like a weasel kind of animal. And I could see that. Here we've got a long tail and the pointy nose over here. I could see a weasel in that picture if I strain a bit. Oh, let me see here. Okay, I've got a little bit of spam here I got to deal with. That's annoying, but thanks anyway. Bye-bye. Okay. We haven't had that in a long time. I guess that's a sign of success again. Anyway, Big Dipper, quite far down and low in the northwest. As we swing back over towards the southern sky, the southern constellations, or the summer constellations, are visible in the low in the southwest, and they're starting to set. Scorpio is just down below the horizon already. This is Ophiuchus, the serpent bearer. Again, looks like nothing at all like it's supposed to. There we go. Augustopus, is that how it is? Interesting how Ursa Major is depicted as having a tail. Yes. Let me duck back there. For whatever reason, most of the cultures that saw this as a bear and faced it this way saw it as having a long tail. And there are a number of stories about how that bear either got a long tail or kept its long tail while all the other animals in the earth lost their long tails. There's a bunch of different versions of that. The Anishinaabe version does not have doesn't use these other stars. It's just the Big Dipper, and it actually puts the bear's nose over here, and then this is sort of the neck, and then the body comes over to here. So it's not quite as detailed of a figure, but it actually, when you overlay the picture onto it, it actually looks a little bit more realistic. So, excuse me. So yeah, it is interesting. And remember, of course, all the constellations, we didn't discover them, we invented them. And your imagination is just every bit as good as someone else's feel free to make up your own pictures here. I actually, for a long time, was seeing Ursa Major as the Loch Ness Monster. Kind of looks like a, I don't know, like a long-necked swimming creature with flippers or something like that. Use whatever it takes to make your own personal connection with the stars, because that's really what it's about. The constellations aren't a thing on their own. They're a way to help us keep track of the sky and try and figure out where things are and see the patterns and the cycles that give us our constellations and our calendar, our cycles of day and night and so on. So whatever it takes to get your own personal relationship with the stars, that's what you should do. Okay, we'll go back over to here to the south. Oh, Rowan says a dancing giraffe. Yes, absolutely a dancing giraffe. That's another good one. Yeah, I think a giraffe is probably the best animal that I've made a picture. I'm a terrible artist, so I've tried to draw my own constellations, but they haven't. They're certainly not good enough to show on the show. But if you draw some constellations, I would be happy to put them on the show. Send me your pictures. Okay, anyway, summer here. Way up in the south, here it is October, and we still have the 3 bright stars of the summer triangle nice and high in the sky. It's called the summer triangle because in the summertime it's easily visible, but as we talked about last month, this time of the year, as the stars are dropping farther into the west, the sun is also setting earlier and earlier, and so those two effects sort of counteract each other, and so we can still see summer stars into the fall. And that's what we're seeing here. So all of the things we've been looking at all summer long are still visible, but as we swing farther over to the southeast and the east, that's where we start to see the new stuff. And probably the brightest thing is the planet Saturn. It's rising over here in the southeast. As the night goes on, it will go across the sky and wind up over in the south, and then it'll set before dawn. So we sort of see it most of the night, but it stays pretty low along that southern horizon. It just does not get very high. And a few of you commented on the amount of smoke that there has been in the atmosphere on the few days that it is clear. You get this smoke that really makes it hard to see things near the horizon. So Saturn views of it have not been great this year. And I've only seen it once through a telescope where the view was at all decent. And I think I posted that to my Scott the Skywatcher page. Surrounding Saturn are a bunch of constellations made of faint stars that I can never find. Saturn right now is in Aquarius. This is Aquarius, the water carrier. I'll leave you to connect those dots however you want. It's over next to Capricorn, the mermaid goat. No, here, we'll move that over. Not that seeing those lines will really help you see the mermaid goat, but I don't know. I've given up on trying to find some of these, especially in the fall, because most of the stars, it just coincidentally are not terribly bright. It's not until you get all the way over here to the east where you start to see some reasonably bright stars. The 4 stars of the square of Pegasus are reasonably bright and reasonably easy to find because they are evenly spaced here. Oh, hey, Kevin, how's it going? Yeah, we can turn on the illustrations. I don't know that they really help. I mean, you know, the pictures obviously go along with the names, but I don't know how the pictures actually fit the stars in terms of like who looked at these stars and said, yeah, mermaid goat. Anyway, but I find that I look for just simple geometric patterns because when you're out under the stars, you don't even have these red lines, of course, you just got the stars. And so it's helpful if you can find patterns that are relatively easy to see, like the big square of Pegasus here. That's a fairly recognizable thing. It actually kind of looks like a baseball diamond. If you think of the top star as home plate, and then you got first base, second base, third base. There's actually even a faint star over here at the pitcher's mound, and here's the bat catcher, and Here's a couple of stars. Maybe this is the manager out yelling at the umpire or something like that. Anyway, baseball diamond works pretty well for being able to find that pattern. Half a flying horse is what it's supposed to be. But again, constellations, you can make them up how you want. I really like Pegasus for my fall constellation because it really does anchor everything else in the sky. You can sort of find your great square of Pegasus. You can see it even from, fairly bright urban skies, as long as there's no buildings in the way, and you can find a bunch of interesting things from there. So the star on the left here, or first base, if you want to think of it that way, is connected to and shared with the constellation of Andromeda. And Andromeda is a princess who is chained up to the rocks on the beach. And these are the stars of Andromeda. To me, it's basically a line of stars and then a second fainter line of stars that sort of parallels it. It kind of looks a little bit like I don't know. I have no idea what it looks like. It's two lines of stars. But it's got some interesting things to look at. In this area, if you start at Pegasus and you count stars 2 to the left, 1, 2, and then you go 2 up, 1, 2, right in there is a wonderful object called the Andromeda Galaxy. On a dark night with no moon, away from city lights, you can see it as a tiny little fuzzy spot with just your eyes. And in binoculars, it really jumps out. And of course, a telescope view can be really, really impressive. Let's just zoom in a little bit here and we'll bring that up. So what the Andromeda Galaxy is the most distant thing you can see, most people can see with just the eye. It is a whole nother galaxy made of hundreds of billions of stars in a big spiral whirlpool shape. And when I say another galaxy, that's because everything else you see in the sky is part of our galaxy, the Milky Way galaxy. And we've talked about the Milky Way before, which you can see in the summer sky very easily. And there's also a winter side of it that we can see, we'll talk about. But it is basically a huge city of stars with billions and billions of stars in it. And this is the only way that we can see what galaxies look like, really, because our own galaxy, we live inside it, so we have a very limited view. But looking out, we see all of these other galaxies. And while this is one of the closer ones, and certainly one of the larger ones in the nearby group, there are billions of these other galaxies out there. If you have a decent-sized telescope, you will never be able to observe all of the galaxies that your telescope can show you. There's just so many of them out there. So Andromeda is a wonderful thing to look at. It's a very distant object, as I said, the most distant thing you can see with the unaided eye. It is 2.5 million light years away. I forget what that is in kilometers, but it's such a large number with so many zeros that there's really no point in talking about it. So astronomers have come up with this with this alternative distance unit called a light year. It's not a unit of time, it's a unit of distance. And it's basically the distance that a beam of light will travel in 1 year, and it's 1 light year is like 9.5 trillion kilometers. So it's a shorthand way. Most of the stars that we see at night are 5 light years, 10 light years, 50 light years, 100 light years, a few hundred light years, most of them. That's how far away they are. There are stars that we can see that are a few thousand light years away, and our Milky Way is about 100,000 light years across. The Andromeda Galaxy is 2.5 million light years away, so exceedingly distant. Phil, you saw the companion galaxies from Hecla, right? There's a little galaxy over here and another little galaxy. This is not a star, it's actually a little fuzzy galaxy. These two dwarf galaxies and a few more that are even farther out are actually in orbit around the larger galaxy. Galaxies are ruled by gravity, and so you've got the big one in the middle and you've got a bunch of little ones around it. Our Milky Way is the same. We've got the Magellanic Clouds and another half dozen or so little dwarf galaxies out there that orbit around us. The Andromeda Galaxy is maybe twice as big as our galaxy. So it's actually the largest one in what we call our local group. We're number two in terms of size there. And there's a couple dozen of these little dwarf galaxies and so on. And all of these things are orbiting around the common center of mass, and things are all moving around. And actually, it turns out that the Andromeda Galaxy happens to be headed in our direction. And I forget how many billion years into the future this happens, but it will eventually pass through the Milky Way galaxy, and the two galaxies will be all discombobulated as gravity shoots stars all over the place. And nothing will actually collide, because even with all those billions of stars in there, galaxies are mostly empty space. There's so much space between the stars that it's just kind of mind-boggling how much space there is. So these two little things would be almost like clouds passing through each other. None of the particles would actually hit. Oh, hey, Abdul, nice to see you. Yeah, 3 to 4 billion years is when Andromeda will get here. And it is pretty impressive. Let me see here. I just saw a couple of things in the chat here. Jackson has said Tolkien made up several constellations for Lord of the Rings. Yes, I actually did a show once on the constellations of Middle Earth and the sky legends and so on. There's a lot of stuff there in that as well, and it's because he basically used the same sky that we have. They're basically alternative constellations and alternative names for constellations in our sky. So you could use those ones if you don't like the old Greek ones. Let's see. We had another one. Oh, Phil asked, why is the belt of Venus called that? Let's come back to that towards the end, because then I can show you at the sunrise, and then we can talk about it. Okay, back to our fall constellations. There's one more fall constellation that I will point out, and it's kind of close to Pegasus and Andromeda. We've got Pegasus, we've got Andromeda here. The W of Cassiopeia, I always think of that as a fall constellation, because that's when it really starts to get up high enough in the sky that it's relatively easy to see. It's really useful because, first of all, it's a circumpolar constellation. It's up all year long somewhere in the sky. And it's pretty recognizable. 5 bright stars, looks kind of like the letter W, and that somebody sat on one side. The side that isn't squished just happens, if you think of it like an arrowhead, just happens to point right back towards the Andromeda Galaxy. So if you're having a hard time finding Pegasus and Andromeda and all that kind of stuff, use Cassiopeia and use that nice unsquished side of her as an arrow, and it'll point you in the right direction. Now, like I say, there's lots of other constellations there. Perseus is another one that is relatively bright. He's starting to be sort of a winter constellation, though, so we don't want to get too far ahead. But Pisces, the fish, is down here. Aries, the ram, down here, sorry. This is a little constellation of a few stars that looks like a triangle, and it's called Triangulum, the triangle. Just above that triangle, there's another galaxy in there. It's a challenging object to see in binoculars, unless you have big binoculars. But M33 is another spiral galaxy in there that can be a real nice view from a nice dark sky. And just to give you a sense of the differences of galaxies, here we have a spiral galaxy that we're kind of looking down on more from the top, with the little spiral arms coming out from the center. Whereas with Andromeda, it's a spiral galaxy, but we're looking at it almost from the edge. We're kind of looking just over one side of it, and that's why you can see all these dark dust lanes and all that stuff. These smaller galaxies are what are called elliptical galaxies, and so they don't have a spiral pattern. They're just kind of a big blob of stars. So they don't have the same kind of structure. But there's many beautiful galaxies to look at in the fall sky, especially if you have binoculars or even better, a telescope. Okay, let's see. Oh, Melissa, yeah, we always recognize Cassiopeia first. Yeah, it is a wonderful constellation because it's so compact and so bright and so distinctive. It cuts through light pollution and everything. So it is really good, a really good signpost. I think even better than the Big Dipper, because the Big Dipper often people don't realize how big it is, and so they're looking for something smaller than it actually is, and that can make it a little challenging. Cassiopeia is kind of as big as you expected, if that makes sense. So I think it really does jump out. You're right. Daniel, oh, the W was for your family name. Yes, of course. Halfway through the year, it flips over and it's the letter M. So I guess it only applies for half the year. But yes, Cassiopeia, the W shape for sure. Now, this is the early evening sky. And when you're looking at the, actually, we can just rewind just a little bit here. When it's just getting dark, I've just rewound to about 20 after 7. There's the sun setting in the west. If you turn around 180 degrees and face east, you actually see that, and it kind of shows up here, there's kind of a different color of sky along the horizon, and then from there up, the sky changes. What you're actually seeing here is the sun has gone below the ground, so the shadow of the Earth is actually being cast out into our atmosphere, and all of the dust and smoke and particles and water vapor that's out there are being lit up by the sun up higher, but you have this dark belt near the horizon. It's called the belt of Venus often, and you can see it in the morning or in the evening, just like the planet Venus. So the planet Venus is visible sort of at that same time as the belt of Venus, and that's where the association comes from. It has nothing to do with the planet Venus other than they happen to be visible at roughly the same time. So that's where that comes from, Phil. And when we get to Venus in the morning, we'll get another chance to take a look at that. Stellarium doesn't do a great job of rendering the colors of it. I actually find that the belt of Venus itself is sort of a dusky purple and maybe sort of pinkish to orange, and then above it is where the sky sort of turns into that twilight blue color. So it becomes very very easy to spot in the real sky. Okay, let's jump forward in the night here. We'll go to about 10:30. Late enough that it's dark, but not so late that we can't do anything else. Another planet rises, the planet Jupiter. Very, very bright at this time of the year. And as soon as it comes above the horizon, it's the dominant light in the sky, basically. It is just underneath Aries, and just where the square of Pegasus was a couple of hours before, that's basically where Jupiter will come up. So if you're not sure where it's going to be, or you got to move around to find a gap through the trees, like I always have to, look for Pegasus, and then 2 hours later, go to that same spot where you could see Pegasus, and you'll see Jupiter. Jupiter is a wonderful planet to look at through binoculars or a telescope. Actually, I had a couple of people send in some images of Jupiter just a little while ago, and someone in the chat was just saying that they saw Jupiter and its moons this summer. Even a pair of binoculars at low magnification will show a planet with some dots lined up with it, tiny little stars. And each night those dots will be in different spots because they are moons orbiting around Jupiter, roughly in the same plane here. So they look like they move side to side, and they just sort of move around Jupiter. In a telescope, that's where you start to see the cloud bands, the great red spot. Sometimes you can see, like in this case, there's a moon right here that is casting its shadow onto the planet. And let's see if I can have this track here. There we go. As you watch minute by minute, everything moves around because Jupiter is rotating, the moons are orbiting, and the moons will disappear as they pass behind the planet. They will reappear. They will come close to each other. There's a lot of stuff always going on and around Jupiter. So it's a great planet to look at through a telescope. I never get tired of it, basically. So it's coming into its best visibility now. It's going to have a great view for the next several months, and it's just going to be rising earlier and earlier each night. So that means by the time winter comes around, it'll be nice and high already and when it gets dark, like at 4 o'clock in the wintertime as it does here. So I'll, be able to get a couple of hours of Jupiter observing in before I even have to make dinner. So I'm looking forward to that. Yeah, it'll be cold, but that's okay. You can dress for that. Jupiter is really going to be a highlight for the next several months. Over nearby, the planet Uranus is over there. I did a blog on the Manitoba Museum's website that had some finder charts that showed you where to find Uranus and Neptune. With a pair of binoculars, you can track both of those down, and they're both pretty well placed for the next month or so as well. So that's something you can look for. It doesn't look like much. It's literally just looks like another star. But in a telescope, you can start to see the bluish color of Uranus and even more so of Neptune. But they're so distant that they're just really, really hard to see. And then the winter things are starting to come up. The Pleiades, when that starts poking up above the evening horizon, the seasons are changing and winter is coming. Taurus, the bull, the V shape of the Hyades star cluster and the nearby Pleiades star cluster, both of these are glorious objects in binoculars, and you can just see dozens and dozens of stars in there. Let me just see here. And then we get into Auriga, the charioteer, and the bright star Capella. This is the region that Andy shot in that picture that we showed at the beginning. It sort of showed basically this whole area here all the way over to the Pleiades. So that was a nice little spot. Craig asks, Jupiter always looks like a white dot in my telescope. Is there a certain magnification you need to see the bands? Well, to some degree, a little bit more magnification will help. But really what I find is most people, when they look through the telescope, they only look for a few seconds before they sort of try and make a change. You have to look for a long time and let your eyes really adapt to the brightness of the planet, because it might look white, but it's got those dark bands on it, but your eyes sort of don't see them right away. So you have to spend a good, 45 seconds, 60 seconds looking without moving anything, without changing the focus or changing the eyepiece or anything like that. And the more you do it, the better your eye will become at picking up that subtle detail. We see the pictures, we see the pictures of Jupiter, and it looks like it's sort of technicolor and things like that. But in the real sky, those colors are somewhat subtle. So you're talking about light tan up against slightly darker tan. And your eye needs to sort of work hard to really spot that difference. It does get better with practice, and it does sometimes get better if you have either a larger telescope or a little bit more magnification can sometimes spread the light out a bit and get rid of some of that glare. Another thing you might want to try, if you've got sunglasses, pop those on. They cut the glare, and they sometimes give you a little bit of contrast and can maybe make it easier to spot some of those cloud features on Jupiter. Let me see. We've got okay, and we've got Tiffany's recipe is being added in, which is awesome. I'm going to be pulling that down later on because I haven't made Pershke for a long time. Okay, let me see. We're going to go forwards in time. If you wait till after midnight, you're basically no longer in the fall sky, you're in the winter sky, because we get a preview of the next season's stars after midnight. And if you wait till 5 in the morning, you basically have the view that we'll see in 3 or 4 months, with Orion the Hunter and Gemini the Twins and all of the winter constellations being up there. But what I want to point out is, over in the east, the planet Venus comes up. And if you thought Jupiter was bright, Venus is brighter. It is incredibly bright, unnaturally bright, a lot of people will say. It gets reported as a UFO or a light in the sky all the time because it just doesn't look like it fits in with, the other stars and planets. It seems excessively bright. It happens that right now, Venus is over in the constellation of Leo, right next to the star Regulus. So Melissa, you were asking about Regulus. Get up at 5 in the morning and look towards the east, and you'll spot it right next to Venus. Now you have to catch it at just the right time, because if you go out a little bit too early, the stars will still be, or Venus will still be very low and it'll be hard to see. If you go out too late, already the sky is starting to get bright. Oh, there's some satellites zooming by there. And once here, I'll turn those off. We don't need those right now. You know, by 6 o'clock, the sky is already starting to brighten up enough that you get this, it'll be difficult to see the other constellations besides Venus. Venus will be visible almost all the way into daytime, though. And just before the sun rises, Mercury comes up. For the next 2 or 3 days, maybe you might see it. It's very, very low. You'll need very, very clear skies towards the east. Those of you out in the west coast where you've got mountains to your east, that's don't even bother. You won't spot it. But Mercury, that most elusive of planets because it moves around and it's always close to the sun, you can catch it maybe for the next couple of days, just in the early sky before everything fades away into daylight. So that is our October sky, a little bit of a summary of the constellations and where the planets are and things like that. There are a couple of other events that I wanted to mention. There's a couple of meteor showers that happen in October. The Draconid meteor shower happens in just a couple of days, but it's very, very minor. However, it's on a list of meteor showers, and so someone on the internet is going to say, hey, there's a meteor shower coming, because they know that people click on those articles and it makes their advertisers happy. So they know that anything space related will do well. So they're going to make a big deal about the Draconid meteor shower, I'm sure. Not worth getting up for. Sorry. 5 meteors an hour at its best. You know, that's almost what you could see on any other night. Just a random night. So it's really not something that I'm going to set the alarm for. Later in the month, on the 21st, 22nd, the Orionid meteor shower, that's starting to get into the territory where, okay, maybe it's worth watching. 20, 25 meteors an hour, that's a pretty decent rate. And in the early morning hours, which is always when meteor showers are best, the moon will be out of the sky this year for the Orionids, so that's a reasonable one to take a look at. All the times and dates and everything are on the Manitoba Museum's planetarium page. You just click through to current night sky, and it's got the calendar there and the article on where everything is and so on. So we can take a look at all that at your leisure. Okay, let me just check here. Wow. I have been yammering on. I'm way over time. That's okay. We'll figure it out. The main event of this particular month is, of course, the solar eclipse. And we're actually having 2 solar eclipses in the next 8 months or so that are visible from Manitoba, actually from most of North America. But depending on where you are will determine what you get to see. There's the eclipse on October the 14th is what's called an annular or a ring eclipse. And it basically, you know, the supermoon, where, you know, when the full moon happens when the moon is slightly closer to us, we call that a supermoon. Well, when the moon is slightly farther away from us, they're now starting to call that a micromoon. But the idea is that the moon gets bigger and smaller as it gets closer and farther from us, because it's not going around us in a circle. It's going around us in a slightly oval shape. So sometimes, you know, it's closer and looks bigger. Sometimes it's farther and looks smaller. Really small difference, but enough to be noticeable for some people, and certainly enough to make a difference for solar eclipses. Because here's the amazing coincidence that gives us these events. The sun is 400 times bigger than the moon, diameter-wise, but it's also 400 times farther away. So in our sky, the moon and the sun look almost exactly the same size. And so when they do line up, the sun disappears behind the moon and it blocks out the bright part, but the faint outer part of the sun, the corona, can still shine through, and we get those amazing total solar eclipse events that don't occur anywhere else in the solar system. I mean, the coincidence of distance and size and so on is really, really unique in our solar system. And so we're very, very lucky. In fact, it's so close that if an eclipse happens to happen when the moon is slightly farther away than normal, the moon isn't big enough to cover the whole sun. And you wind up seeing a whole ring of sunlight around the moon. And that's called a ring eclipse or an annular eclipse. That's what we have coming up on October the 14th. And if you happen to be in this path here, that's where you will see the ring eclipse or the annular eclipse. Basically, it starts out in Oregon and then goes down through to Texas, across the Gulf of Mexico, down through most of Central America, and into Colombia and Brazil, and then off to the ocean there. I'm not going to be in that path on Saturday, although I am going to be over here on Friday, and so we'll talk about that too. It's not much of a better view actually in Florida than it is here in Winnipeg. If you're in the west, though, you're pretty close to this line. And the closer you are to this line, the more of the sun gets covered up during the eclipse. So this is the view we're going to see here in Winnipeg, 44% or something like that of the moon going across the sun. And it'll take about 2.5 hours to slowly sort of creep up, get to its maximum, and then fade away. And that will be the partial eclipse. If you're closer to that line, if you have a view, from our friends out in the West Coast here, you're going to be more like 85%, which is enough for people to start to notice the sky actually getting darker. When the sun is only half covered, there's still so much sunlight coming out that it doesn't really feel like it gets darker. But closer to that line, there'll be some interesting effects. And if you do have the opportunity to be within that line, I know a few people are heading down to different spots. Send us your pictures. The thing about a solar eclipse, though, is that you cannot look at the sun without your eyes getting damaged. This isn't just an eclipse thing. Any time, any given day, if you were to look at the sun repeatedly over the course of a few hours, you could permanently damage your eyes. And if you looked at the sun with binoculars or a telescope, you would instantly blind yourself permanently. So do not look at the sun without the proper protection. And there are only a couple of safe ways to look at the sun, which we're going to talk about. You can get eclipse glasses, those little cardboard things with the mylar filters. A lot of people think that the silver stuff in there is just the silver stuff from helium balloons. It's not. It might have the same basic structure, but there's a special coating on the solar glasses that filter out all the harmful ultraviolet and infrared radiation from the sun to protect your vision. If you used mylar from a balloon, you will blind yourself. So don't do that. Also, it's kind of a shame, but if you go online and you search for eclipse glasses, you will find tens of thousands of places selling them. They're usually some random person that you've never heard of, and they may very well have just gone and bought some helium balloons and cut them up and put them in their own cardboard frames. There's a lot of fake and unsafe glasses out there. Get them. The Manitoba Museum shop has them. You can get them there. If you have worked with a telescope store before or done mail order from a place before, they'll be able to source proper stuff from you. If you're here in Winnipeg, probably the museum shop is your best bet. And you can just go to the museum reception desk and they can hook you up there. I think they're $3 a pair. So, you could probably get ones for $2 online, but then you might go blind. I don't think it's worth the extra dollar, right? So anyway, that's one way to safely observe the sun. Another way is to come down to our eclipse viewing party. We decided that we should just get a whole bunch of telescopes together with safe solar filters and go down to Assiniboine Park. We're going to be set up by the Leaf, the new big garden indoor attraction. That's sort of at the southeast end of the park. And you can just come out and join us and we'll look at the sun. We'll have a bunch of safe telescopes. There'll be eclipse glasses there as well. And it'll just be a good time. So we're going to watch that. It starts about 10:28 for Winnipeg. The peak is around 11:42, I think it is. And then it ends by about 1 o'clock. So, you know, if you get there at 10 o'clock in the morning and you're there till 1, we'll have a nice afternoon under the sun, watch the eclipse. We'll have feeds from other places. There are a variety of live streams that are going to be in the path there that we'll be able to see the annular effect as well. Of course, weather permitting. That's the problem with October. If we have weather like we've had the last couple of days, we might not be able to see the eclipse. We're going to be there anyway. Even if it's raining, we'll have like the monitor set up and we can watch a feed from somewhere where it's close. But I really hope it's clear so we can get together and actually do some observing together. It'd be nice to see folks come out if you're here in Winnipeg or the surrounding area. And if you are elsewhere, your local science center or planetarium or astronomy club is probably doing the same thing. So just take a look around and see. You may even just have someone that has a telescope in your town or whatever that is going to set up at a local park and just share the view with people. So just look around and I'm sure you'll find a way to be able to enjoy that. We'll be live streaming again. And so you can join us here at Dome and Home as well. If you're not able to make it here, you can join us remotely. So the eclipse is something you have to be concerned about safety-wise, but not afraid of. It's easy to observe safely. We have a whole bunch of information, again, on the Manitoba Museum's planetarium webpage. I wrote a whole blog on eclipse safety and how to make a eclipse projector so that you can get a close-up view and all sorts of things. So you can check that out and come on down to the eclipse party at Assiniboine Park on Saturday the 14th, starting around 10 o'clock. And that will be our observing highlight certainly for October. There's actually a lunar eclipse 2 weeks later, but it's not one that's visible from here, and it's such a minor eclipse that I'm only mentioning it for academic interest. It's not something that we'll be able to see in a very, very minor event. But eclipses often come in pairs like that because of the way the geometry lines up. And we'll have to do a thing on, maybe for the April 2024 eclipse, we'll talk a little bit more about how eclipses happen and things like that. But I've already run over time, so I don't want to do that. All right, let's see. Yes, some very good. Phil has asked about the asteroid they brought back samples from. Yes, let's talk about asteroids because it turns out that there's a whole bunch of neat asteroid missions going on. There was the OSIRIS-REx spacecraft that just recently landed on or grabbed some samples from an asteroid and then just parachuted down into the desert in Utah, and they are having a press release or press conference tomorrow to show off what they found. I heard today that they actually did get samples of the asteroid. In fact, they got more than what they expected they might. So that's kind of cool. And so tomorrow, NASA's doing a press conference on the details of that. So asteroids are left over from the formation of the solar system. They're the things that didn't get made into planets. And so by studying them, we get a sense of what the early solar system was like, because here on Earth, the surface has been changed with volcanoes and glaciers and all that kind of stuff. We don't have the really earliest rocks to study. And so asteroids are one way to sort of look back in time, I guess. The other thing is that if you want to know about the very insides of planets, the cores of planets, it's really hard to do that, because the core of the Earth, for example, is a big lump of metal that is molten, and it is very, very deep inside the Earth, and it is very, very hot and under very, very high pressure. It's not the kind of place you could just, dig a hole deep enough and take a look at it. And because it's molten, it's been changing all this whole time. It's been mixing around and things like that. If only someone was smart enough back when planets were forming to grab one of them and stick it in the freezer and just like preserve it. Well, it turns out that in the asteroid belt, there is something like that. There's an asteroid called number 16 Psyche, and it is, here, let me just go back to here for a minute so I can get the picture lined up. There we go. Asteroid Psyche is, we believe, the metal core of a planet that was forming in the asteroid belt, but Jupiter kept tearing it apart and preventing it from actually accumulating all the rest of the asteroid stuff. And so that's why we have a bunch of debris out there instead of a planet. And because it's not big enough to have volcanoes and that kind of activity, it has essentially been kept in the deep freeze of space. And so the Psyche mission is going to fly off to this asteroid, and it is going to take close-up views and orbit it and really map out what we think is an exposed planetary core. It's mostly metal. In fact, it's mostly nickel iron with a few other metals. Someone did a calculation and figured out that if you brought all that metal to Earth, it would be worth $10 quintillion. Of course, if you brought that all to Earth, the commodities exchange would collapse. And anyway, I don't think it's quite that simple, and we're not bringing it here anyway. But regardless, it is a very interesting world to study. I got the wonderful opportunity to join NASA's social media team for this launch. So I will be flying down to Kennedy Space Center on Tuesday, and on Wednesday we'll be touring around. We'll get to see the launch site and talk to some of the project scientists and engineers and things like that. And then on the Thursday is when it's scheduled to launch at 9:16 in the morning, Central Time here in Manitoba. And we'll be covering that launch live, so we'll be going live there. And I'll also be going live anywhere else they will let me go live from, because we're going to be backstage at NASA. I think it's going to be awesome. There's going to be all sorts of cool things happening, and I'm really looking forward to getting to see that, but also getting to share it with all of you folks. So stay tuned for basically the middle of next week. Particularly Wednesday, and I'll try and get as many images and short video clips that I can provide as possible, and then join us for the launch on Thursday. So the Psyche spacecraft is ready to go. It was delayed about a year because they were almost ready to go last year, and then they discovered some software things that might be an issue, and they decided to rewrite big sections of the software, and so that delayed the launch. It was scheduled to launch today, this morning actually, originally, and then they found that some of the thrusters that are used to position the spacecraft, cold gas thrusters that just shoot out nitrogen and stuff like that, fairly simple devices, had some kind of quality control issue, and they wanted to inspect all of those beforehand. Because basically, you launch the spacecraft, and then it sits out there in space for a number of years, and then everything has to just work perfectly when you get to your target. And while you want to go, it's probably better to hold off another week to make sure that, the things that point the spacecraft aren't going to blow up after a few years. So it's really, really complicated to get one of these things off the ground. And while I was a little frustrated that I had to change all of my travel and all of my childcare and all of that stuff, and I might have to again if they bump it more. It's just the nature of the beast. So I'm going to be down there hopefully next week, and we will watch what's going on here. And I really am excited about this mission because it's really the last kind of object that we haven't visited. I mean, we've sent spacecraft to rocky planets and to gas giant planets and to Kuiper belt objects like Pluto, and to stony asteroids, and to comets. Literally the only kind of world we haven't gone to is a metal world. And so that's what Psyche is. It's going to a world that is totally made of metal. Anyway, I used to be a metalhead when I was in high school, so it's bringing back a lot of stuff for me. All right, let me see here. It is, we are going a little bit over time, but that's okay, because it is time for
Cool space stuff!
Here's the asteroid sample that landed in Utah. Basically, the spacecraft, after going to the asteroid and after picking pieces of it up, basically dropped off a little capsule as it sped by Earth. And the capsule parachuted down and landed in a Utah test range. And I don't know, some of you may have watched this live. It was pretty cool as it came in, and it landed just like this, and it looks, I mean, what's the scale there? Well, I had to put in another picture. It's really not that big. It looks it looks a lot more imposing when it's all by itself. It's basically the size of a good sized cooler. But in there are samples from an asteroid, and like I say, that's going to be coming out in the tomorrow, and some of the details that are going to be released. Hopefully, we'll at least get some pictures, and they'll tell us a little bit about any of the exciting first impressions that they have from these samples. This is the asteroid Bennu, where it came from, and Bennu is, you notice that it's all covered with loose rocks. It's really not all that solid. I mean, it's a pile of rock that is kind of held together more by gravity and friction more than any other kind of structure. So it's fairly loose, and so it was easy to collect pieces from it. But a lot of asteroids, we think, are actually these very loose conglomerates rather than being, you know, one solid chunk of material. And so these will tell us different things about the, you know, that formation of the solar system and how all of the planets and things like that came together in the early days. And let's see, let's move on here. Oh, this is another thing. We've been following Jeremy Hansen, Canadian astronaut, as part of the Artemis II crew. They got to meet their spacecraft last week, went inside and actually sat in the spaceship that will carry them to the moon in, 16, 18 months or so. There isn't really a full date for that because there are a whole bunch of moving parts on this. But of course, Jeremy and the other 3 Artemis II crew will fly out around the moon and then back to the Earth in the first test of the Artemis spacecraft with humans aboard. So we're watching that, and hopefully all of the technology all starts to come together and we get to see a Canadian go around the moon in the next year or two. Can't do cool space stuff without James Webb. This one came out 4 hours ago. At least that's when I saw it. It wasn't there when I did the research yesterday. Europa, one of the 4 moons of Jupiter that you can see in binoculars. It's probably, my prediction, probably the place in the solar system that we will discover life. We're not going to find it on Mars. It's going to be on Europa, because Europa is an ice moon with a big subsurface ocean of liquid water. It's got active volcanoes underneath, just like the volcanoes at the bottom of the Pacific Ocean that have all sorts of colonies of life there that don't depend on sunlight. It's very, very likely that there's something there. Well, the Canadian instrument that is on the James Webb Space Telescope did some imaging and has basically determined that there is carbon, which is one of the key constituents of life, on Europa in the form of dry ice, basically. So frozen carbon dioxide on Europa. That's one more ingredient for life that we didn't know was there, and now we know. I think it'll be very cool in the next, I guess it's next year when they launch Europa Clipper, or the JUICE mission, pardon me, which is the Jupiter Icy Moon Explorer. I forget how the acronym goes, but basically it will fly out to Europa and it will fly through the water volcanoes that there are there to see if there's anything living in the water that's underneath. I mean, that's coming next year. That's pretty cool. So yeah, very, very new stuff from James Webb. And this was a shot of the Orion Nebula, one of my favorite objects. James Webb does an amazing job of being able, with its infrared light, to peer through the dust and get down right to the very center. And they discovered something that we weren't expecting, which is what James Webb seems to do, basically. So when we started looking at planets, we thought, well, okay, planets form around stars, and the rocky planets are all close to the star, and the gas giant planets are all far from the star, and then the ice planets are all around the edge, because that's what our solar system looks like. So that must be the way everything is. And then we started finding exoplanets, planets around other stars, and we found that our solar system is a freak. Nobody else looks like our solar system. Ours is really, really unusual. You've got Jupiter planets in closer than Mercury. You've got Neptune planets everywhere. You've got 5 or 6 Earth planets and no gas giant planets. There's all these different kinds of solar systems. Ours is very unusual. So we're starting to realize we have to think broader when we're looking at planets. Well, now we have to think even more broadly, because in the Orion Nebula, there are planets that are not associated with a star at all. Okay, you might think that, if you've got a solar system and there's like a collision or something like that, maybe a planet gets shot out into space or something. That wouldn't be that unusual. Well, there's a whole bunch of them. But they're not individual planets. They're in pairs. You can't come up with a simple way to have 2 planets ejected from a solar system after forming around a star and yet still stay together. That just doesn't math properly. So these planets probably formed without a star, just on their own. And we didn't think that planets would be able to form in a situation like that. You usually need enough gravity and enough energy that a star would form. It's just the way gravity works. It pulls everything towards the center. How did these planets get there? They're calling them jumbos because that's the acronym is Jupiter Mass Binary Objects. Because basically it's imagine 2 planet Jupiters orbiting around each other, no moons, no stars. Weird. What does this mean? No idea. And to be honest, this is like 2 of the 40 images that came out in the last week or so. It's just impossible to keep up with all of the amazing discoveries that this device is bringing. I remember when Hubble went up and we talked about the Hubble Space Telescope, and after 10 years, it was clear that it was the most productive scientific instrument in history, just because it was churning out such amazing data and such a lot of it. James Webb is leaps and bounds beyond that with the amount of stuff that's being discovered. It is really, really amazing. Okay, let me see here. Great. Thank you all for joining us. I think that's it for our cool space stuff for this year, for this show. So we will be live whenever the Psyche mission launches. That's currently scheduled for October 12th. We will be live at the solar eclipse at Assiniboine Park. You can join us in person or you can watch us online. That's from 10 o'clock to 1 o'clock. And then we will be back again the last Thursday of October to do our preview of the November sky and get back into our sort of regular monthly thing. So thank you very much for joining us. You can always send us information or requests or any questions that you have through the usual venues, Facebook or YouTube. I'm Scott the Skywatcher on Facebook, and you can hit me up at Manitoba Museum as well. Thanks for joining us. I hope you have a great week until I talk to you again, and I hope we get some clear skies. Have a nice night, and we'll see you soon.